Okay, so really quick, round 2 of my ZVS driver. The last one that I built on the breadboard over here, on this small Radio Shack breadboard, was not performing well. And I think it had a little something to do with the way that I had crisscrossed the components on the board. At radio frequency, these things start to interfere with each other. So the other hypothesis I had was that this thing was just not able to push enough amperage. The primary pathway for current is through the coil here, through the MOSFETs, and to ground. So, I've got my ground wire here, and this entire center terminal block is ground, and this is the path of positive voltage, 12 volts, 12 positive volts, through the resistor and to the gate. Well, I'm not going to try to describe the circuit to you. The bottom line is that I chose a more robust construction format here, and everything is in line, and it creates a better pathway for the current, a little bit more linear pathway for the current, and I think that the circuit interferes with itself less. And so therefore I no longer need a voltage regulator on this circuit, and that was a huge win, because now the battery is able to provide as much current as the circuit is able to draw. And you can see that the performance is actually significantly better. This is a pretty wide spark. I can widen it up even a little bit. Well, it's screwed in, but it's a fairly wide gap in the spark. And when I turn it on, you can really hear that quite a bit more current is getting pushed through this thing than it was previously. So I'm going to turn it on now. And you can see the spark, and I'll turn off the light. And that's really loud. And not pleasant, but you can see that there's a lot of current getting pushed across there now. And I'm optimistic that when I connect this now to my capacitors, that I'll be able to fill up my capacitor and determine how much voltage this thing is actually pushing. And it will be very interesting to see how much power this thing is pushing. And I'm also very interested to change the driver, because at some point, well, the driver it's a resonant driver, but it's taking the resonance of this coil, right? Which is cool, but this is the primary. So it's getting the primary to resonate and not the secondary. I'm sure you can get resonant gain from that. You can certainly get resonant rise from that. And it's possible that through that alone, well, who knows. But in any case, I'm going to do some power calculations on this. And why do my eyes look like they're totally crossed? I'm going to calculate the power on this and see what's coming out, what's going out, and what's coming in. And I'm going to do a real easy test on the output. I'm going to hook up my capacitors. Where did they go? Right here. These will be my smoothing capacitors. And then I'm just going to draw DC current through some resistors at high voltage. And it should be fairly easy based on monitoring the current and the voltage to determine how much power is getting pulled out of this resonant driver. So that's my plan, and we'll see how it goes. Compare the input to the output and get a sense of the efficiency of this resonant driver. That's coming up next.